The premise of the demonstration of Cantor's theorem is untenable. Wow! Cantor proved Cantor's theorem in 1874. It tells us that all real numbers, or real number intervals, are uncountable. This is a crucial step in the establishment of infinite set theory. Cantor's theorem has been opposed by many people since its publication. And until today, the opposition has not disappeared. In fact, the proof of Cantor's theorem is wrong. How could this be wrong? Cantor also published other proofs later. Cantor's proof process concealed premises that could not be stated clearly. If the premise of proof is wrong, what is there to prove? The basic ideas of Cantor's theorem can be found in scattered locations in his specious paper on a property of the totality of all real algebraic numbers, which was published in Journal in 1874. The demonstration that Cantor felt very convincing was published in 1890. The key points of the demonstration are provided below. Set that 0, 1 is a countable set. Then there exists a sequence, i.e., A1, A2, A3, An, which is composed of all the real numbers in this interval. Each real number can be expressed by a decimal, and set that the rational number can be expressed as an infinite decimal, then we have this. Next, we construct B equals this, set that if pkk equals 1, then bk equals 9, if pkk not equal 1, then bk equals 1. Hence, b is a real number in the interval 0, 1, but it doesn't equal any real number in the above sequence, which contradicts the hypothesis. Therefore, 0, 1 is uncountable. Similarly, any interval of real numbers is uncountable. The premise of the above demonstration is false. The real numbers can't be written as infinite non-repeating decimals because the proposition that we want to demonstrate is a pure mathematical proposition, but not an applied mathematical one. As is known to all, the rational numbers aren't infinite non-repeating decimals. However, it should be noticed that the irrational numbers are only themselves and they aren't infinite non-repeating decimals either. The infinite decimals are dynamic numbers and indefinite numbers. But the irrational numbers are static numbers and definite numbers. From the perspective of the sequence, the irrational number is the limit of the infinite non-repeating decimal, which can be regarded as a sequence of decimals, but not the sequence or the dynamic process itself. Cantor's error is that he equated the irrational number with the dynamic process of the infinite non-repeating decimal, i.e. the sequence of decimals. That is to say, Cantor confused the limit of the sequence with the dynamic extension of the sequence. There is another method of demonstrating Cantor's theorem, which is intuitive. Of course, this method can only give the proof by contradiction. 2. Set that all the points in 0, 1 can be sequenced as 1. Let us enclose the point with coordinate A1 in an interval of length 1/10, the point with coordinate A2 in an interval of length 100th, and so on. If all points between 0 and 1 were included in the sequence 1, the unit interval would be entirely covered by an infinite sequence of possibly overlapping subintervals of lengths 1/10, 100th. The fact that some of these extend beyond the unit interval does not influence our proof. The sum of these lengths is given by this geometric series. Thus the assumption that the sequence 1 contains all real numbers from 0 to 1 leads to the possibility of covering the whole of an interval of length 1 by a set of intervals of total length 1/9, which is intuitively absurd. This demonstration is applicable to any other unit intervals. Therefore, Cantor and his supporters held the opinion that Cantor's theorem was tenable. However, there is also a fatal error in the premise of this proof by contradiction. It is considered with no reliable arguments that the mathematical holders of the measure are points or numbers. In fact, on the basis of the current number point model, These holders can only be the blanks between points in the continuous interval. We will elaborate this proposition when discussing the measure in the next section. If we consider the blank between points to be the mathematical holder of the measure, then we have delta I equals 1 minus 0 divide n. And formula 2. Only in this way can we comprehend the measure reasonably. The false conclusion drawn from the absurd demonstration that imposes the length on the points or numbers, which aren't the mathematical holders of the measure, is definitely untenable. Furthermore, the theory of functions of real variables changes the right things into wrong things, while demonstrating that the mistake in the classic rationale, calculus, doesn't exist through making another mistake, which contradicts the original purpose of this theory, that is to support and perfect the classic rationale for calculus. In the classical rationale, the integral is defined by formula 3 or 4. However, in the theory of functions of real variables, and can only be countably infinite while there are uncountably infinitely many numbers in the interval a, b, and every number in this interval can be represented by x. According to Cantor's theorem, n can't enumerate all the numbers in a, b. Therefore, the equality 5 isn't reasonable according to the theory of functions of real variables. As a matter of fact, although Cantor's theorem is provable by contradiction, the indirect method, direct constructive proofs, could not possibly be given even in principle. True mathematicians like Poincaré, Brouwer, Weil didn't approbate the unserious views from Cantor to Hilbert.